Prove algebraically that the recurring decimal 0.47, where the 7 is recurring, can be written as 43 over 90. So the first thing I'm going to do here is I'm going to let x equal my decimal, which is 0.47 recurring. So the 7 bit is the bit that keeps repeating because the dot is above the 7 in the question. I'm then going to multiply this by 10, and that's going to give me 10x equals 4.777 and so on. What I'm trying to do here is I'm trying to get the bit after the decimal point to match up exactly. At the moment it doesn't. One of them goes 0.7 and then continues, and one of them goes 0.47 and then continues. So I'm going to multiply this by 10 again to give me 100x. 100x is going to equal 47.7777. Now this does match up and I've got what I need. What I'm going to do next is I'm going to ignore this part at the bottom and I'm going to subtract these from each other. 100x, take away 10x, gives me 90x. And 47.7 recurring, subtract 4.7 recurring, gives me 43. So I now have that 90x equals 43. The final thing I'm going to do to work out what x equals as a fraction is I'm going to divide both sides by 90, which gives me x equals 43 over 90. And that was what we were aiming for in the question. It's really important with these prove questions that you don't start from what you're trying to prove. You end with that. And we have ended with x equals 43 over 90.